Now when we're multiplying polynomials, what we're going to be doing a lot of is distributing. Okay, so if I have something outside of a parentheses, I'm going to distribute that and I'm going to multiply it by everything here inside the parentheses. So I'm going to take 5 and I'm going to multiply it by 3x, and that would give me 5 times 3 is 15, and I just have one x there, and then 5 times 5 gives me 25. That's a positive 25. Now I would not be able to add these because these are not like terms. This would be my final answer, 15x plus 25. Those cannot be added. Now we'll also be distributing with variables and exponents, and I want to make sure we kind of understand what that looks like. For example, I have 3x to the third power outside the parentheses. I'm going to distribute that to 4x to the fifth power. Now when I multiply 3 by 4, I get 12. Oh, not 21. I get 12. But when I multiply x to the third times x to the fifth, that's going to give me x to the eighth power. So what it looks like is it looks like I'm kind of just adding these two exponents here. And the reason for that is because when I take x to the third, that's literally x times x times x, right? X to the third power. I've got 3 x's that are being multiplied. X to the fifth is x times x times x times x times x. I've got 5 x's being multiplied. Whenever you do that, whenever you take x to the third power and you multiply by x to the fifth power, you're saying that you have 8 x's that are being multiplied. So that creates x to the eighth power. So what it looks like is it looks like we're adding exponents when essentially we're not. We're just, I've got 3 x's being multiplied, 5 more x's being multiplied. That gives me x to the eighth power. So it's always going to kind of look like I'm adding the exponents. All right, and I would distribute that again, 3x to the third times negative 5x squared. That would give me negative 15 x to the fifth power, because I've got x to the third over here times x squared. All right, and it's going to look like I'm just adding those exponents again. And this would be my final answer. Don't try to add those two terms together and get anything else, because x to the eighth and x to the fifth, those are not like terms. Okay, so that would just be my final answer. Those two terms would be what my final answer would be. And we're also going to be multiplying a binomial times a binomial. In other words, I've got two terms on the left and I'm multiplying it by those two terms on the right. And what I'm going to do here is I'm going to distribute, but I'm going to distribute twice. So before we just took one term and we multiplied it by everything over here. I'm going to do that again, but I'm going to have to do that twice. So I would multiply x times x, and that gives me x squared. Then I would multiply x times 5, and that's just going to give me 5x. Now I've taken care of the x. I'm going to have to do the same thing with this 3, and I'm going to multiply 3 times x, and that gives me a positive 3x. And then 3 times 5, that gives me 15. So I'm distributing the x times everything over here in the parentheses, and then I'm going to do the same thing with 3. I'm going to multiply it to everything in that parentheses, and once I'm done, I'm going to look at my answer, and I should have 4 terms. I multiplied a binomial times a binomial, and I'm going to look and see if there are like terms, and there are. I've got a 5x and a 3x. Okay, those are what we call like terms. When you think back to polynomials, when we first started looking at what we call like terms, if they just have the same variable, it's like adding 5 apples to 3 apples. They're the same. Whatever x is, they're the same. I can add those together and I would get 8x. Nothing else has like terms. There is nothing else x squared, so I just bring that down. And there's no other constants or whole numbers, so I would just bring that down. So this would be my final answer. I've combined my like terms. I've distributed twice, and that's as far as I can go with this. Now we've looked at the distributive method where we've been distributing both terms to everything inside the parentheses on the right. But there's another way we can do this, and you might have seen this before. This is called the box method, right? And now I could distribute, x times everything in the parentheses, and then negative 3 times everything in the parentheses, and that's going to give me 6 terms. I could do it that way. But there's another way you can do this, and we call this the box method, and you might have seen this before. Now what I'm going to do is I'm going to draw myself a little box here, and I have 3 terms over here, so I'm going to make 3 columns, and I have 2 terms over here, so I'm going to make 2 rows. Alright, now this is essentially doing the same thing, but what I want to do is I'm going to take all 3 terms over here and I'm going to put them on the top. I had x squared plus 3x minus 1. So I just took these 3 terms and I put them on the top of my 3 little boxes up there. And now I have x minus 3. I'm going to put x minus 3 over here on the side. And what I'm going to do is I'm going to multiply whatever's over here on the left by whatever's on the top of the box. Okay, so I need to make sure that and this will help me keep up with, instead of distributing, a lot of times it's easy to not distribute once and not even notice that you missed a term. But here I've got boxes and I'm going to make sure they're all filled in. So I've got negative 3 over here on the left. I'm going to multiply it by x squared. Negative 3 times x squared is negative 3x squared. Okay, and then I've got negative 3 on the left times 3x on the top. Negative 3 times 3x is negative 9x. And then my last term, negative 3 times negative 1. And that gives me 2 negatives, gives me positive 3. Alright, now I'll go to my next term. I've got x down here. I'm going to multiply it by x squared. And that's going to give me x to the 3rd power. I've got x times 2 more x's. That's 3 x's being multiplied together. Then I'm going to do the same thing. X times 3x up here. X times 3x is 3x squared. And then x times negative 1 is just going to give me negative x. Okay, and now, like we did before, we were checking for like terms. I'm going to do the same thing here. I'm going to see if there are any like terms in any of these boxes that can be added together. Okay, for example, I've got negative 3x squared. Are there any other terms that are x squared? And yes, there are. There's an x squared term right here. Those are like terms. I can add those, but in this case, negative 3 and positive 3 x squared cancel each other out. They're opposites. Alright, and I'll look and see, is there anything else? Well, I have a negative 9x. That's an x term, and I have a negative x down here. I can add those together, and those are actually going to combine 2 negatives, just add to give me a bigger negative. Same signs, add and keep. Now x to the 3rd, I don't have anything else x to the 3rd, so I'll bring that down, and I don't have any other whole numbers, so I'll just bring that out of the box. This would be my final answer, and I would have got the same thing if I had been distributing like we did before. Either way you do it, box method, distributive, either way it's going to give you the same thing, so it really doesn't matter which way you choose. Now this is an example from the homework 5.2, and it's given you an expression, and it says which expression represents the area of the rectangle. When we multiply polynomials, most of the time on a test, you're not just going to get 2 things to multiply together. They're going to give you something like an area model or some kind of example where you have a length and a width. Now when we're talking about area is length times width. It's one side times the other side. So here they're giving you an expression, and they're saying what expression represents the area. Well, area is length times width. All that means is I'm going to take one side and I'm going to multiply it by the other side. So we'll be distributing exactly how we just were. 3x times x, 3x squared. 3x times negative 6, negative 18x. Okay, so if they give you something and they give you an area model, all that means is multiply. Okay, so with expressions, just give an expression that's equivalent to the area, you would distribute 3x times x minus 6. Now there's some vocabulary that we want to be familiar with, and especially on the test and in the homework, there's something called terms. And in the homework, they will actually ask you how many terms does a polynomial have, and they'll give you a set number of terms. So we need to be able to answer questions about terms, and terms are actually pretty simple. It doesn't have anything to do with exponents or the variable. It's just, look at this expression right here. I've got x squared plus 5x plus 6. Each one of those is a separate term. So 1, 2, 3. If I was asking you how many terms are here, there are 3 separate terms. They can be separated by a plus or a minus. Those are terms. It doesn't matter, I could have x to the 25th power plus 10x to the 17th plus 5x to the 8th. When we're asking about how many terms there are, just look at how many different things are being added together. There's still just 3 terms. Don't complicate that. When they're asking you how many terms there are, they give you something crazy. Just look at how many terms there are. For example, on the homework, we got 5x squared minus 4x to the 5th. Those are only 2 terms. I've got 5x squared. That's a separate term from negative 4x to the 5th. They can't be added together. They're not like terms, but those are 2 separate terms. All right, another thing we're going to be asked to do is to factor out a GCF. And what I want to do is I want to look at both terms, or however many terms we have, and see if they have something in common. A number that will go into both of these terms. For example, 3 goes into 3 and 3 goes into 9. That's something they both have in common. Now, this term here has 4 x's. This one has 3. But they at least have 3 x's in common. They both at least have that many. So my greatest common factor for these 2 terms would be 3x to the 3rd, because that's how many numbers that will go into all of them and variables that will go into both of those terms. That's something that they both have in common, and that's our greatest common factor. And when we're looking for a GCF, we may have more than 2 terms. We may have 3 terms, 4 terms. However many terms we have, I want to look for something that all 3 of these terms have in common, a number that will go into every single term. What is the biggest, the greatest common factor? Now I know that 5 will go into all 3 of these numbers evenly. 5 goes into 5, 10, and 20, and that's the biggest number that will go into all 3 of those. Now they may not all have an x, because if you're looking over here, I've got an x over here and an x over here. These 2 have an x in common, but they don't all 3 terms don't have an x in common. So I'll look for the next thing. Now they all have a y in common. I've got y squared, y to the 3rd, y to the 4th. Now if you're looking at these, y squared is y times y. This is y to the 3rd, and this is y to the 4th power. That means y times y times y times y. I want to look at how many they actually have in common. Well, this one has 2. And that's the lowest number of y's that I have. So they at least have 2 y's in common. Okay, I've got y squared, y to the 3rd, y to the 4th, but they at least have 2 of those y's in common. Now they don't have more than that, but that's the least amount of y's that they have in common. So they have a 5 in common, and they have y squared in common. So that would be the GCF for those 3 terms. Now when we're factoring out a GCF, it's important that I understand, am I factoring out a positive or a negative? And that's going to be determined by the leading coefficient. Now this is a negative 14 in the front. Whatever's in the front, the sign of that first coefficient, that's going to determine what I factor out. So let's say I'm looking at these 2 terms, and 14 and 10, they both have a 2 in common. 2 goes into both of these numbers. That's the biggest number that'll go into 14 and 10. But I'm going to factor out a negative 2 because the coefficient in the front, that was a negative 14. So that's how I know if I'm going to factor out a negative or a positive. Okay, so look at that leading coefficient that number in front of the variable here. I've got negative 14. That's how I know that I'm factoring out a negative 2 and not a positive 2. Okay. Now they both have x squared, so I would say they both have a negative 2 in common, and they both have an x squared. So my GCF for these two terms would be negative 2 x squared. Now if I, I could reverse that, and let's say, for example, I had the opposite. Let's say I had 14x squared minus 10x squared. Okay, the only thing different here is that the sign, or that it's a subtract in the middle. If I were to factor out a GCF from these, I would factor out a positive 2x squared. Because in this one, the leading coefficient is positive. What determines what I factor out is the leading coefficient. That's why this first term over here, I factored out a negative 2x squared instead of a positive 2x squared. It's based on the leading coefficient right here in the front. Now on the homework, you'll be asked which of the following is a factor of, and they'll give you a binomial or a trinomial or something like that. And in this case, they give you 3x squared minus 12x. To figure out what a factor of these two terms are, just factor out the GCF. 3 and 12. They have a 3 in common. I can divide a 3 out of both of those terms. And they both at least have one x in common. So I'm factoring out a 3 and an x. Whatever I have left over, that's going to be the other factor. Now when I divide this, 3 divided by 3, the 3's cancel. So I'm left with x squared divided by x, and that's just x. And then negative 12x divided by 3x. Here the x's cancel. Negative 12 divided by 3 gives me negative 4. Okay, so these are my two factors. Once I divide it out, I found the GCF and I divided it out. The GCF was 3x. Whatever's left over right there, those are my two factors. So I've got x minus 4 and I've got 3x. Okay, so 3x and x minus 4. Those are the two factors of the binomial. Those are two things that if I were to multiply those out, if I multiplied 3x by both of those, it would give me exactly what I started with. That's why we call it a factor. It's something that would multiply to give me the original expression